Hello everyone, it's Calder from 19. Today's day 67 in my challenge day. And there's not much time for today's recording. So I need to stop recording that shorter than earlier videos because I need to go to class. So what I'm going to do is basically about the setting up the shader binding table. So during the weekends, I set up some graphics pipeline and a ray tracer pipeline so, uh, by getting a proxy address of function. The name is vk create ray tracing pipeline KHR extension. And also, as you see that there is a creation of the shader modules about ray generation shader and the mist shader and closed shader. And I created some shader groups for them. So as I mentioned in the earlier video, the ray generation shader group is a group itself, and the mist shader is also a group itself. And we need to specify the heat shader group by setting the closest heat shader explicitly. So that's just a difference between the mist shader and ray generation shader and the closest heat shader group. And we create a pipeline creation. And specify the pipeline creation layout information and the sum of the wiki shader stage and the shader group infos, and plug into the specified information to this pipeline creation info about the shader stage data, which is pointer, and the size of the group counts, and the stages and groups, and the layout. The layout means that uh, you know a layout is just a pipeline creation layout information, and the descriptor layouts are specified into the pipeline layout information. So that's just a difference. Okay, run it. I hope there's no error. Okay. See, the difference is, you see that I just remove the extension format after compiling to the Aspire-B format. So this name is Raymond's shader. Chan shader. Closest tweets. Let's try out. There are also some relative paths. some there's no shaders. Okay, there's no error in the runtime. So I think after setting up the shader binding table, finally we can start the actual ray tracing logic from this week. For device ray tracing platform group this page. I can get this. So first, to get a shader group handle size, we need to query the wiki piece group device ray tracing pipeline properties, which is extension properties. Let's try out. Let's figure out how to do that. Okay, so to get the VK physical device, which is that ray tracing pipeline properties, it is can carried by the pnext chain. If we try to get a device property two, which is an extension version of the get device properties function, then we can just plug into the pnext to about the specified the physical device ray tracing pipeline properties struct to this original the device properties to struct. Then we can just query with the pnext chain. Let's do that. So inside ray tracer H header file below the helpers, let's add okay, nice. Below the helpers. Right. Tools HR. So by initializing with the struct type for each of the ray tracing pipeline properties and the device properties too, and we plug into the ray tracing pipeline properties to the pnext chain of the device properties. And then finally, we can call the vk get physical device properties too to get to fill out these ray tracing pipeline properties and return it. And we can use it inside of where is it? Let's create a new function. Description. And here we need to create shader binding table. Name is void create turbine. And the role of the shader binding table is just basically they do some relationships work between uh, top level acceleration structures and the several shaders that used by the ray tracing pipeline. So whenever the top level acceleration structure need to be referenced by some of the shaders, we can just using the binding table to access some of the shaders related to this top level acceleration structure. Okay. Below the ray tracing descriptor set, there this function set void create Finally, we can create the ray tracing pipeline properties. Curry cat. Let's specify some options. Handle size is provided by these properties. Also, you can insert two. Handle size aligned is I don't have it, so let's figure out. So there's some formation for the how to get the aligned size for the ray tracer. We can just follow this formula. Actually, I don't know what means that. But, so there is no guarantee the alignment correspond to the handle group size. Surrounding all is necessary. Improvement size as described may constantly work on the hardware, but now possibly to leave some data recording extra data without which random size to the next using the form. Okay, let's ask about this formula to the GPT. Size is the original size of memory, and alignment the alignment boundary. You get a mask with the lowest piece to 0. Having no space to accommodate the original size. Having a credit for Okay, so if we subtract the one from the alignment, it seems that when it was the binary value with a four, subtracting one would give us three, right? Which is this form, and we do that plus size, and it can be some of the bit field of one. When it encountered when it meets the another bit field one, which is the same position, it can be round up to the next bit field. And then if we do that, if we do the complement of the alignment one, alignment minus one with AND operation, we can just subtract by the lowest bits again. Okay. I think that's how the roundup works. This is just fine for just right now. Let's move on to again. Let's go to the raytracer.h and load the apples first. You insert two with an align function. Get align size. Just want to search value. Align. I will just implement this inside here. Value align minus one. Okay. Size. The parameter of this size to so alignments. This can carry by extracting from pipeline properties. The name is alignment. So group handle alignment. By utilizing these two variables, we can just get aligned size. So size to group counts. The group counts, which is just simply equivalent to size of the BK shader group's information. Shader groups. count and the handle size align, which is rounded up the size with the alignment padding. And the shader binding table is just basically a buffer, VK buffer, that we can just accessing from the host side with and the memory state is followed by the host. So we need to set some memory usage flag as host memory coherent. I think so. As you can see, to make a memory property host current bit, host visible bit, as a transfer source, the shader device address and shader binding table. Let's just copy all of that. Okay, buffer usage flags, SBT usage flags. Okay, this is for the memory usage. Okay, I need to stop recording just right now. So if I have enough time to record more, then I will do that after the class. Okay. Anyways, thanks for watching today's recording, and as always, thanks. I'll see you next video. Bye.